About 100 days ago, we landed a 2-ton SUV on the surface of another planet, on the surface of Mars. This is one of the first pictures we took there with our rover, looking out at Mount Sharp. To me, I kind of cry a little bit, choke up when I see this picture. Why Mars, and why do we look at these other planets? And part of it's to understand our own planet. What's the context for us? We live on this amazing planet, but Mars is a lot like Earth. It's similar in size. During the daytime, it can get up to about 70 degrees in the Fahrenheit. So it's so like Earth, but at the same time, this is a barren landscape. You don't see any trees, you don't see any cactuses growing, anything like that. So today I want to tell you about the story of how we got from Earth to Mars and why it's so cool. So one of the things we start with is a blank sheet of paper. We knew from the previous missions in 2004, Spirit and Opportunity, there was water on Mars in the past. But what's the next step? We're looking for even more fundamental level of what does it take to have life survive? And so to have that kind of knowledge and understanding, we have to carry a massive amount of instruments. We have to carry the kind of labs that people actually have whole rooms devoted to on Earth inside of essentially a small car. And what we did was we shrunk it all down to something that weighs about as much as I do, and then put it inside of this rover that weighs as much as your car does. And that rover is now on the surface of Mars. But it's so heavy, and so it kind of takes a special challenge for us to make it all work and come together. So we look at our tool of what do we have to land stuff on Mars? And one of the options is airbags. We've done it before. Airbags are pretty cool. They bounce around a lot. You could never put a human inside of an airbag because they would get squashed. But the problem with airbags is the airbags that you see here, which landed the smaller rover, it's like 400 pounds, the entire rover, were about the size of this room. So you can imagine the size of airbags it would take to land a 2-ton rover on Mars. And then they have to be actually made out of materials that don't even exist today. So it would be some kind of exotic material that we'd have to develop and may or may not work. So what about rockets? And this is the way we've you see all the rocket ships landing in the old movies and everything else, all rockets on the bottom. It's a cool idea. It works when they're pretty light still, but the problem is these rockets have to be pretty strong to actually softly land you on Mars. And so they would be so powerful that they could actually dig holes into the ground, and then you would just end up inside of a hole and not be able to drive out of it. So not the best design. But what if I could take the rockets and move them up? And that's kind of what we came up with. It's actually a rocket-powered jetpack. We call it the Sky Crane. And basically what it does is this big rocket sits on top of our rover, and when we're ready to land, the rockets kind of hover in place, and we slowly lower the rover to the ground. And then we touch down, we're actually on the wheels, we're ready to drive day one. But in addition to that, the scientists were like, well, we actually want to go somewhere interesting. The last 2 missions, they're really cool, but they basically landed in what was like landing in the plains or the desert. Not very exciting. We all know from the exciting places on Earth are the places like the Grand Canyon and things like that. And those are for the scientists, the most interesting because you see that whole layer. You see years and years of history all in one place. And the same thing is true for where we landed. We wanted to land somewhere that was unique, that had this crater walls where things had been dug up for us, where mountains were pushing things up. But the problem is, if you landed with the older systems, you could have landed on the side of that mountain and just tumbled off. Could have been the side of a cliff. Could have been the crater wall or a large boulder. So we needed a kind of technology to help us land in a very small area. And that was this little guided entry from Apollo. We took it from the 1960s. We flew over just like the manned people because they have to actually pick up men. They can't just land all over the place. And then we landed spot on in the middle. And in fact, it's so spot on that when we did it, we were able to, basically like a quarterback, launching towards Mars. It was like a quarterback, though. The quarterback was in Seattle and throwing at a receiver that was moving here in Giant Stadium. That's how accurate we were. It's kind of awesome. But you only get one shot, and so we actually have to design a system that we can build and test and operate. And so it's not just about, can we get it to Mars, but then if it's only one chance, how do you make sure that one chance goes so well? And so there's all these processes we have to make sure that things are built properly. And then we go out to the desert and we drive it around and we test it. We fly things in F-18s to make sure the radar systems work at high speeds. And then, most importantly, we actually test the team to make sure they know how to operate it. We don't want to accidentally miss it because we go, sent the wrong command, and now it's just going to be rebooting forever. So that guy, Fred, there, he did a lot of that. And then we launched it on this rocket to Mars. And the entire thing, we landed 2,000 pounds on Mars, but the entire thing actually was about 10,000 pounds when we lifted off from Earth. All the fuel and the solar arrays and everything else that we needed. And again, we're so accurate that we landed in this little pinpoint on Mars. And in the meantime, though, we had to design a landing system that worked. And I told you about the actual physics of it, but here's the catch. Mars is about 14 minutes away from Earth from light speed. which means that if I tried to control it with a joystick, I would be always controlling to 14 minutes in advance, so it wouldn't work. So we had to give it all the smarts and all the knowledge that it needed in order to make it happen. And so what we did was we built in all these smarts and algorithms and everything, and we told it, here's what you're going to have to do. And it goes from basically the speed, 5 times the speed of a speeding bullet to about a baby's crawl, all within about 7 minutes, which is called the 7 minutes of terror, because I was about to throw up. But today we're on the surface of Mars, and this was one of the panoramas that we took a couple days after we landed. And I think it's amazing to me because you look at this and you can see the Grand Canyon, you can see your own planet, you can imagine walking on the surface. And so what we're going to do and what we're continuing to do is to understand what makes Mars so special and what makes Earth even more special that we're all here together today. And so we'll see where curiosity takes us, not just our rover, but our sense of exploration. Thank you.